Hello. Okay, I was thinking maybe it might be a good idea to do a simulation in LTSpice of that emitter-follower amp that for which I made a video not too long ago. I'll put a link into that video right now. All right, so let's build that circuit that we design. So it's very simple, LTSpice. So I just did a file new schematic, and those are all the symbols for whatever components you want to put. Okay, so let's start with the source, the voltage source, AC voltage source. So you go into component, left click, and then you go into voltage. So I'm going to put it somewhere. Yeah, if you want to turn anything, you do a Control R. That turns it. I'll just leave it like this. So left click wherever you want, and then escape. So let's put the ground right away. Escape, let's put the wire. Okay, done. So maybe it's time to right click. We're gonna edit. Okay, so it's not DC, it's AC, so it's gonna be a sine. So let's do offset nothing, amplitude 1 volt. So the peak to peak is going to be -1 to 1. Let's put a frequency, I don't know, 1.5K. And that's it. Here you may want to change the name here. So you do a right click on it. Let's call it V in. Okay, so next. Next is the capacitor. Capacitor, this one we're going to turn it. So Control R. And I'm going to put it, I don't know. Let's put it here. Escape. Let's draw the wire. So left click, left click, left click. Let's put the value now. So this one, let's do 10 micro. So U is for micro. Okay, what's next? It's going to be the voltage divider stuff. So I'm just going to put a wire, stop it here. And let's put a resistor here. So that's our R1. And the value, we said it was about 1K. It's not 1K, it's less than that. It's probably 0.8, but let's do 1K. It doesn't really matter that much. So 1K, let's put the wire. And on the other side, you also have a resistor. And this is going to be 1K as well. And this one goes to ground. So let's put the ground. Let's click. Okay. Let's do. So what else? Let's go this way. I'm just gonna go up to here. Here is gonna be the DC voltage source. So put voltage. Let's put it. Here. Let's hook it up. Okay, let's put the ground on the other side. Yeah. Okay, let's put the value. So that's going to be my 9 volts. Or just 9. Okay, what else? at some point we have to put the transistor. So let's do it now. So it's going to be in there, and look for, just take one NPN. Where are we going to put it though? Here is fine. So let's change it to a 3904. Pick new resistor 3904. Excellent. So we can connect the base. Okay, what's next? We need RE. Let's put RE. Okay, put the ground. Let's rename them because R1 is correct, R2 correct, R3 is RE. So RE. What else we need? We need here. So this. We need the capacitor here. So let's put the capacitor. Let's turn it. Control R. Here's the capacitor. C2, correct. And then we need the load. Okay, so let's put values here. RE, we said it was 450 or thereabouts. Let's put 470. So 470. C2, it has to be pretty large. So let's do like 200 micro. Doesn't really matter. And R3, which is actually the load, so let's call it RL. Let's put a value of 100 ohms. I think we got everything. Okay, so we got everything. At this point you may want to save. So let's call it emitter-follower. Okay. So at this point maybe we should do a DC analysis. So let's do simulate, edit simulation command, and we're gonna do a DC up. So that means we are doing a DC up here. So let's, and then you click on the running man to simulate. Okay, so you get all this. You get all the voltages, all the currents. But what you can do is you can just, for instance, let's look at this node, and on the lower right, it shows this is node N001, DC operating point, 9 volts. Oh yeah, this is the V out, by the way. Okay, so now let's check the VE. So it's about 4 volts, 3.77. What else can we check? We can check the current through RE. So it's 8 milliamps. We were shooting for 10, and it also gives you the power dissipated, so 30 milliwatts. Okay, so we are good with this. So now let's do the transient simulation. So again, simulate. simulation command, and it's going to go transient stop time. Let's put 1 second. You can put less, but you put it somewhere here. So now this one is commented out and this one is going to execute. Okay, so let's see the voltage at the output. Yeah. So just as soon as you come next to the node, it's going to show that probe. So then just left click. It's going to show up here. Okay, so may want to zoom. So it's between 0.9 and minus 0.7 and 0.9. You can look at the, what else can we look at? Maybe the current through RE or the current through RL. The current through RL, you can look at that, sure. So the current through RL, you're going to see it on the right side. So it's between 0.7 and 0.9. So that's all fine. Now, the question is, okay, and then if you want to delete the traces, you can just right click, delete this trace. Right click, delete this trace. Now the question is that how much can we push that thing? Can we actually drive a speaker here? So let's say, I mean, to drive a speaker, you're going to need to increase the current through here for sure. So let's up it up to like 100 milliamps, 100 milliamps. I think a 3904 can handle 200. So let's do 100, which is pushing it a bit. So let's change this one. Let's put 47 here. Let's put 47 here. And here, let's see if we can go all the way down to 8. So let's simulate like a speaker. It's a crude approximation, but let's say we have a load resistance of 8 ohms here. Let's see what happens. So let's just run it. And let's look at the, first let's look at the this guy. So you get, and also the current. So the current is about, it goes up to 100 milliamps. I want to see the power though. So the power, you press Alt and then left click. Alt and then left click. That gives you the power. So let's get rid of the other one, the other traces. So that gives you the power, and if you want to know the average, you just control left click, control left click, control left click. That's going to give you the average. So you get 32 milliwatts. It's not much. I'm not sure you have enough to, because this is like even the smaller speakers like 1 watt. So 32 milliwatts, not that great. You may want to worry about the transistor because it may overheat. I think the 3904 can handle 600 milliwatts tops. So you don't really want to go past half of that. So let's look at the power here, power dissipated. So again, Alt and left click. So let's get rid of that one, which was the one on the load. I think it's going to be too much. So let's do the average, which is control and left click on the name of the trace. Control and left click. Yeah, 300 milliwatts. So you're kind of pushing the transistor to the limit here. So I think you could get something. But I mean, if you want to drive a speaker, you should really use like an op amp like the LM386, which is designed just for that, to be able to drive a speaker using like a 9-volt battery. That's what the LM386 op amp is used for. This was just to show how to use LTSpice, and basically you just want to verify that what you did on your piece of paper in terms of design is correct in terms of how it runs not in reality, but at least in the simulator. Okay, so I'm gonna stop here. If you like this kind of content, please like, comment, subscribe, and I will be making more. See you.